respected professors and dear scholars, Assalamu alaikum. I am Amkawar Tizada and today I am here to deliver my presentation on the topic boron of graphite carbon nitride based electrochemical sensor for detection of carbofuran under the kind supervision of Professor Dr. Najma Meman. So let's begin with the introduction of pesticides. Pesticides are chemicals used to control or eliminate pests. Over a few decades, pesticides have been used frequently, causing a very serious environmental and health issue, remaining in the environment for a long period, being highly toxic. This map displays pesticides imported across the Pakistan. Standard methods like GC and HPLC are commonly used for pesticide detection due to their reliable, precise, and sensitive nature. These techniques have limitation in complex preparation and complex procedures. Electrochemical sensing has emerged as a preferred technique for detection of pesticides due to their selectivity, low cost, and wide detection range over the on-site analysis. So, substantial research has been done on the detection of pesticides. The following table summarizes the detection of pesticides through the different modes, through the different electrodes having a different pH and their potential window. So, we propose using electrochemical method to detect the various pesticides, noting that the different classes have different potential window. Our plan is to develop electrode on sweet pesticides to screen the pesticides which have a wide potential window in water bodies. So literature highlights boron drop diamond electrodes for their stability and potential window. However, these boron drop diamond electrodes are highly expensive, posing a cost challenge. So considering advancement in the nanomaterial, we aim to experiment a boron-based material to determine their potential window. For this, we synthesize boron graphite carbon nitride. Graphite carbon nitride is a stable form of carbon nitride, and when we induce boron into it, so it increases surface area and porosity, which is a promising candidate for electrochemical sensing. Aims and objectives: assessment of boron drop graphite carbon nitride for determination of carbofuran. So experimental work. Melanite was utilized to synthesize graphite carbon nitride in an inert atmosphere. Then boric acid served as a boron precursor was thoroughly mixed with it and then heated at 550 in the furnace for 3 hours. Then the resultant product was a light yellow powder, which is known as a boron graphite carbon nitride. So PGCA material was dispersed in a distilled water through fumigation, and naphthalene was added, which is the conducting binder, and the suspension material was dropped on the surface of glassy carbon, and after the drying it was used for vector sensing. So this is a 3-electrode system in which the reference electrode is a silver chloride, and the glassy carbon is used as a working electrode, and for the counter electrode we use the platinum electrode. Real samples were collected across the district of Jamshoro, Indus River and Potri, and they were stored in the refrigerator. Then after the samples were collected, filtered, cleaned and pre-concentrated through solid phase extraction, and then evaluated with acetonitride. Results and discussion. These are the FAR spectra of BGCM and GCM, in which the sharp peak at 802 per centimeter shows the tristisine unit, which is the key part of GCM, and the spectra, the part of the spectrum recording in fingerprint region was magnified to identify the photometric peak at 925 per centimeter as a carbon boron bond. So stem images of graphite carbonate BGCM, figure A and B are the Nitrogen absorption porosimeter analysis of GCN BGCN was shown, and the carbon-based material are porous, and according to the International Union of Pure and Applied Chemistry, these both curves shows the type of 4, indicating that the carbon are porous. So these are the BGF force distribution curve of graphite carbon nitride and PGCN, and the surface area of GCN is 8.5. After the incorporation of boron, it becomes 20. These are characterization of electrode, EIS and CV was done on the KCl and ferrocyanide. In ES spectra, semicircular curve of liquid plot is monitored. Whether the semicircular curve, greater would be the resistance and vice versa. And the figure B shows the cyclic watergram, which indicates a great current response for the modified electrode in compared to the sphere. Different electrolyte medium were tested for detection of carbofuran. The maximum current was monitored at phosphate buffer pH 7. This is the DPV response of pure glassy carbon and BGCN electrode at the phosphate buffer pH 7. To observe the analytical parameters, calibration was performed, and the calibration study was successfully conducted at DPV mode. To set the linear dynamic range concentration, the concentration was start from 0.33 micromole to 2.02 micromole. And to monitor the selectivity of the electrode toward the carbofuran in presence of different interference. So interference agent was tested with the equal concentration of carbofuran in the electrochemical cell, and the electrode show an obvious selective response for carbofuran. This is a comparative table shows that the LOD of BGCN is compatible to the other modified electrode. So conclusion, boron graphite carbon is successfully synthesized. LOD that is 0.27 micromole and LOQ 0.832 micromole under the range. So these are the references. Thank you.
Thank you so much, Ms. Patawar, for your nice talk. Now we have a last presentation of Ms. Mehrunisa. Ms. Mehrunisa, please come and present your work.